Welcome to another episode of Math with Mrs. Wilson. Today we're starting a new chapter, and this is section 9.1, Solve Quadratic Equations Using the Square Root Property. By the end of this section, you will be able to solve quadratic equations of the form ax squared equals k using the square root property, and solve quadratic equations of the form a parentheses x minus h squared equals k using the square root property. All right, so the square root property just says that if x squared equals k, so x squared equals something, then x is equal to the square root of that something, or x is equal to the negative square root of that something, or we can just write it as x equals plus or minus the square root of k. Let's solve this problem. And the first thing we're going to do is take the square root of both sides, because that's what the square root property tells us we can do. So if we square the parentheses, or we take the square root of the squared parentheses, the squared cancels. And then we need to take the square root of 5 over 4. But remember it said that it was going to be plus or minus. So that's important that we put the plus or minus. And then we're going to rewrite this as x minus 1/2 is equal to plus or minus the square root of 5 over the square root of 4. We can simplify the square root of 4 so that we have x minus 1/2 is equal to plus or minus the square root of 5 over just 2, because the square root of 4 is 2. Now we're going to add 1/2 to both sides so that we get x is equal to 1/2 plus or minus the square root of 5 over 2. Then it says to rewrite these as two solutions. So we're going to write this as x equals 1/2 plus the square root of 5 over 2, and x is equal to 1/2 minus the square root of 5 over 2. And you could write that as a single fraction if you would like, since there's a common denominator, but we'll just leave it like that. Let's try this. So you're going to go into your groups and try that problem. After you check your answers, go ahead and turn your page. Similar to what we learned about solving radical equations, when we solve quadratic equations, we want to get the squared part isolated. So the first thing I'm going to do is subtract 4 from both sides, so that I have 5a minus 5 squared is equal to 100. Then I'll divide by 5 on each side. And then I'll take the square root on each side. And when I do that, I have to remember that it's plus or minus. Now I'm going to solve for a by adding 5 to both sides. So I get 5, or a equals 5 plus or minus the square root of 20. I can simplify the square root of 20 because that's 4 times 5, and 4 comes out as a 2. So I would have a equals 5 plus or minus the 2 square roots of 5. Now I'm going to write that as two answers. So a equals 5 plus 2 square roots of 5, and a equals 5 minus 2 square roots of 5. And that is our answer. Before we do the try it, I would like to do the next one, and note what it says. It says sometimes the solutions are complex numbers. And so in last chapter we talked about complex numbers. So let's try this. We can take the square root of both sides, and we get 3r plus 4 is equal to plus or minus the square root of negative 8. But the square root of negative 8 is imaginary, so we're going to rewrite that as 3r plus 4 equals plus or minus the square root of 8i. Now I'm going to solve for r. So we will subtract 4 from both sides. So we get 3r is equal to negative 4 plus or minus the square root of 8i. Next we divide by 3. And I'm going to divide each of these by 3. So that now we just have r is equal to negative 4/3 plus, I'm going to simplify that square root of 8 to 2 square roots of 2, I over 3. And usually we don't put the I in the fraction, so I'm just going to write it next to. And then we also have r is equal to negative 4/3 minus 2 square roots of 2 over 3i. So these are our two solutions to our equation. All right, I'm going to pause the video. I'm going to allow you to do both try-its in your groups. Go ahead and check your answers for these. The left side of the equations in the next two examples do not seem to be of the form a parentheses x minus h squared, but they are perfect square trinomials. So we will factor to put them in the form we need. And the way that we can tell that they're perfect square trinomials is because the 9 and the 4 are perfect squares. Right, so the square root of 9 is 3, the square root of 4 is 2, and if we double those, we get 12, right? 3 times 2, is 6, times 2 is 12. So the way that we'll write this is 3m minus 2 and 3m minus 2. If we FOIL that, you can see that it checks, and so we get it equal to 25, because that's just the other side of the equation. You just bring that down. I'm going to write this as a square, because it is squared. It's a perfect square trinomial. Right, so this is A, this is B, and this is C. Now we're going to take the square root of both sides, so we get 3m minus 2 is equal to the square root of 25, which is 5. And now we just solve it. Add 2 to both sides, so 3m equals 7, so m equals 7/3. That's one of our answers, but also we have to remember that when we take the square root of 25, it could have also been a negative. So adding 2 to both sides, we get 3m is equal to negative 3, so m is also equal to negative 1. I'm going to pause the video and allow you to do the try it, and we'll come back and check the answer. Go ahead and check your answer, and then we'll come back and write a summary as a class, thinking of 2 things that we learned today.